Could this be proof of an other universe? Since beginning its hunt for the dark, distant secrets of the cosmos more than 2 years ago, the James Webb Telescope has demonstrated an ability to observe a world of structures that, by our understanding, shouldn't exist at all. A theory finally comes in here where our current models have hit the wall, the British physicist and Nobel Prize winner Roger Penrose being the most famous of its proponents. The Big Bang wasn't the start of everything. It only represented the start of one cosmic chapter, and after that, a more cosmic chapter began. In fact, Penrose is absolutely convinced that the universe has always been under a fixed cycle of destruction and death. The latest discoveries, in fact, go so far as to show that he is right, and amazingly. Then there were these mysterious Hawking points, Penrose said, which included the leftovers of a previous cosmos. We are limited to infinity, at least. This may seem obvious, but despite many astronomers' suspicions, including myself, that the universe is infinite, from our perspective, it's an infinitesimally small fraction of the whole. Our spherical field of view is correctly named the observable universe, the area from where information could reach the Earth since the Big Bang. Technically, then, the distance to our natural line of sight, the so-called event horizon, is also 13.8 billion light-years. But that's not true. And really, for the cosmos, space has been expanding forever at this point, so distances traveled also expand in the past. Ultimately, the distance to the observation horizon is estimated at 46.3 billion light-years. It's exciting to me, because each point in the universe has its own observable universe, which means that the part of space that will forever remain unknown to us can be seen by a civilization millions of light-years away if there is one. These cosmic blinkers mean experts can only guess as to what's happening beyond our line of sight. Some say devastating destruction has swept the structures there, and while many researchers believe that the structures there actually correspond to local universe structures, others think the invisible wonders of space are far more bizarre than we can even imagine. The black hole that recently appeared on the star charts, although, would have been bizarre enough had we not been caught by surprise a few weeks ago by the James Webb Telescope. According to the scientific naming, Li 568 was christened with a scientific name, which had already been around for 1.5 billion years since the Big Bang. But strangely, the gravity monster supposedly devoured matter 40 times faster than can technically be possible. But let's be clear. But it is by no means an astronomical exception. This is a case of a whole series of black holes turning up far too massive for their formation in the early universe, as we now know. Among them are the quasar J1120-0641, an active galactic nucleus now in the cosmic twilight era that already weighs 1 billion solar masses. But the closer examination with MEG, Webb's mid-infrared instrument, did not reveal any extraordinary feeding mechanism that the researchers had hoped to see. It just so happens that we don't actually know how a supermassive black hole would have been fully matured when the cosmos was only 5% of what it is now. Since our existing models are unable to explain those cosmic, premature babies from which we observe the universe, we need new ideas to explore. Sophie Kidman is speaking of the sort of things that sometimes have the potential to revolutionize our understanding of the universe. The exciting thing about this question is that nothing is ruled out, said the University of Cambridge astrophysicist when asked if the notoriously massive black holes could have originated from structures even before the Big Bang. A direct collapse could have produced the massive black holes we find now in the early universe, say some people. Many publications also tell us these are proving observations. That is, if black holes grow efficiently, they don't have much time to grow from a very light seed. But although Kidman emphasizes that this model is just one of many explanations, it does come up with a groundbreaking premise, namely that there actually was something before the Big Bang and thus for our universe, the cyclic model, the end as a beginning. The Webb discovery also demonstrates that current cosmology is approaching its limits in many ways. in fact producing an astronomical crisis in the first place. And, after all, news that there were 6 impossibly massive galaxies out there that were as massive as the Milky Way is today, around 13 million years ago, had already been spreading since February 2023. Unfortunately, this unexpected finding sharply contradicted our theories regarding the density of matter in the early cosmos, as well as about galaxy evolution, and the inexplicable objects became quickly known by one very unorthodox label: the universe breakers. But some galaxies in the young universe were more and more efficient at converting gas into stars than others. Apparently, it was the judgment of a University of Geneva research team, which studied 3 galactic heavyweights, also called the red monsters, for their presence in Webb images. One part of our theories is that galaxy formation happens more slowly in dark matter halos. They hold atoms and molecules, and they pull around themselves structures that are bound by gravity, and galaxies are formed from this. Although generally only about 20,000 or less of the captured gas is converted into stars, that's a whopping 50,000 in the case of the red monsters. For now, still an unsolved mystery in astronomy, we don't really know how the structures did it some 1 billion years after the Big Bang. What we do know for sure is that something has to have happened back in the earliest cosmic chapters that set things up for the spectacular growth of galaxies. But what if that's not true? Simply put, what if the groundwork for the universe's development was not the Big Bang, but before that? So if we had done that, we'd have hit the heart of an awesome theory that Roger Penrose has been flying around for a little while now. The British mathematician and physicist, who was honored with the Nobel Prize in Physics in 2020 for his research on black holes, is convinced that the universe is cyclical. That is why, instead of always cited as the beginning literally everything, the Big Bang appears to Penrose as the transition between 2 eons of 2 cosmic cycles. According to the motto, "Every end is preceded by a new beginning," the universe would continue to expand until all matter has been disintegrated and become light. Penrose believes that no matter what, this extreme environment, in which nothing has a time or space reference to anything else, will inexorably result in a new Big Bang ad infinitum. Likewise, black holes will also annihilate in each of these finales as well, and thus immortal it in the succeeding universe in the form of a special remnant, which bears testimony to the prior cosmology. But that's not all, and he claims to have found exactly these telltale traces in the cosmic microwave background. This is, in detail, about many circular spots that can be seen in the Planck and in the WMAP satellite data. For the record, if you were wondering, the cosmic microwave background radiation, or CMB for short, is a relic from the early days of the universe, created roughly 380,000 years after the Big Bang around the time the universe recombined, and is all around the entire universe today. Before this, to understand why the discovery of things called Hawking points could be so groundbreaking, we have to first understand that in the cyclic model, cosmological inflation comes before the Big Bang. That is generally the phrase used to describe a phase of extreme rapid expansion of the cosmos in which, just shortly after the universe's creation, the cosmos experienced an unparalleled growth spurt. Now, however, if we front-load this inflationary growth prior to the birth of the universe, then we get the result of the exponentially growing future of an earlier eon. On the mathematical side and the side of physics, they are all right, and in principle you adjust from eon to eon with minimal change. Supermassive black holes are an exception, as these would have almost entirely annihilated their environment, impossible galaxy clusters, before the end of a cosmic chapter in which the black holes themselves would have self-evaporated into Hawking radiation, but with the radiated energy powering a single Hawking point for all of time in the subsequent universe. The photons resulting from this process would be found now in an expanding region, but it does not become visible until the new cosmos finally shows itself in the microwave background radiation. Such a Hawking point would be, on paper, a disk, with a diameter of the full moon, and in fact, such was seen in the microwave background by the data cited. In more detail, the ominous spots are integer multiples of the average CMB temperature fluctuations. In fact, experts had expected that by cosmological inflation, all such features would have been wiped out completely. With all of this exciting discovery and so many cosmological inconsistencies the James Webb Telescope exposed, is it possible that we live on the one universe but not the one universe at all, but only just the cycle that is happening right now? That is, in fact, what the astronomical debate focuses upon, and it is by no means done, although there are plenty of people that find it rather amusing. The cosmos, in fact, may indeed be subject to an eternal cycle of the destruction and rebirth, but that leaves some basic questions unanswered. What then constituted the beginning of the cycle? Isn't it all starting somewhere in eternity? If mankind one day succeeds in completely understanding the world in which it dwells, will mankind succeed in mastering the world? Well, who knows? You must surely understand that if you never wanted to miss another new video from us too, you should now click the thumbs up and the subscribe button. You can stay in the loop and be a part of our community. From now on, we'll start seeing you soon.